Hello and welcome to DCG's development update. We are here with the platform, core, and mobile teams to give you an update from the past 2 weeks. We are planning this session for 60 minutes. And if you have any questions, please feel free to add them below in the live chat. And please use a Q or question prefix so we will know that it is intended to the Q&A session at the end. All right. Hope you enjoy. Without further ado, let's start with the core.
I'll start with the overview. Yeah, I'll start with the overview very quickly. So me, Igor, and Ivan were working on platform. The biggest thing that we worked on and our big goal that we're trying to work towards is releasing a version that is, as far as we understand it, not attackable, meaning that we're going to put out a version of platform that anybody can try to destroy as best they can by sending tons of queries or by sending tons of transactions, of state transitions, of transfers, of withdrawals, of creating identities. Anything that somebody can think of, that we should try those attacks, blasting the mempool, full mempool, like anything. And that's the big next goal. We're still aiming to achieve that goal this month. And because of that, these last 2 weeks were extremely, extremely heavy with, going through hundreds of thousands of lines of code and making sure that there were no attacks. And, because we had never really done that before, we found a lot of them. And we have fixed a lot of them. Not to say that we expect the release to leave a lot, but yeah, I mean, this is a normal development process where you don't write the perfect code the first time, so you always want to make sure that you have another pass at it for polishing. Okay, so that was me, Igor, and Ivan. Lukasz worked heavily on TenderDash to make a lot of improvements. He'll talk about them that were found generally around the stress tests. Paul has been working on improving our strategies and the platform text user interface. And Evgeny and Odysseus have been working on GroveDB. There's actually a very cool demo that Evgeny is going to show later. And I have been working on code review and documentation. Okay, so let us start. We're going to start a little bit out of order this week, and we're going to start with Lukasz on TenderDash.
Yeah, hi. So basically, my effort was mainly focused on outcome from the stress testing, where we had multiple changes to the TenderDash that increased either performance or stability of the consensus protocol, and also introduced multi-threaded interface for Drive. So that all work was done during the last few sprints or few weeks or maybe even months. And right now we have finalized everything. I will not get into details because it was all discussed in previous calls, but basically high level changes are that we implemented gRPC between Drive and TenderDash, which uses multi-threaded approach. So right now we can have multiple threads. We can control what types of requests go to Drive through which thread, and that all works. And during the last sprint, I was mainly busy with testing all that stuff, adding some unit tests, creating correct pull requests that were contained only one feature, and quite much work was involved in order to review everything correctly, test it, add unit tests whenever possible and reasonable, and to merge that all. But finally, we released Tender Dash 0.14.0 Dev 4 together with the bindings for Rust's library that contains all that effort. So the version that we have right now is quite stable under load. For the next sprint, I will still work on some minor issues we detected, and we will do further testing because that's basically my goal for the next few weeks, to just like do some maintenance and stabilization of Tender Dash. Yeah, and that's more or less it. So as you can see on the screen, quite much work was done. It was all finalized, except for one feature that we decided is not needed anymore. That's it. Ivan, do you want to go next?
Yeah, thank you. Thank you, Lukasz. Hello, everyone. So last demo, we announced the pretty big work what was done on the drive improvements. We are separated our processing of ABCI messages. So in the previous system, all the queries check TX is the check what we do on transaction before it come into mempool, and other consensus related events what Drive is handling, such as propose the block, process the block, and finalize the block. So we separated query and check TX, and we handle them in parallel. And so they not interfering and with the consensus, and the goal is that they won't slow down the block production, and vice versa, the block production does not prevent user to query the data from the platform or verify the transactions before they will be included in the mempool. Since so previously all the calls were sequential and run in one single thread, and now we have multiple threads where we're handling queries, when we're handling check TXs in parallel, and we also have a consensus thread where we processing sequential events for the block production. It's open a new I would say new area of problems when we're dealing with multi-threading. And this sprint, we actually worked on improvements on this area. So in the PR from the previous demo, our multi-threading one, we used the parking lot library for.
No, we hadn't even been at parking lot at that point. That was after.
Oh, really? Okay, I forgot. Thanks. So it's many things. It was many changes since that moment. Yeah. So we have the platform state, which represents the current execution state for the blocks, where we're storing what the current protocol version is, what the current block height, what is the current block time, and things like this. Basically the state what we want to keep between the blocks and during the block execution. And since this data now is using in different threads, we use the shared lock basically to have the safe access to this data. And previously, like initially, we used the read-write lock implementation from the Rust standard library. And this implementation has some downsides depending on the operation system where you're running the code, because read-write log from standard library, it uses the native implementation of the locking system and I don't remember exactly. I guess on Mac OS they're all fine, but on the Ubuntu you have some interesting effect. Then, sorry,
On Linux.
on Linux, yeah. So some interesting effect when you have the readers like who read the state, for example, the query or checktx, it's not altering the state, it's not updating the state, so they only read, and they acquire the access to read the state, and you have many readers as you want, or you could have only one writer. So with the original implementation read-write log, you have a problem when you have many readers who are trying to acquire the read access, and you have a writer who is trying to write the data to the state. And in our case, the writer is actually a consensus thread, the block production process. And if you have many readers in the queue, the writer cannot acquire the lock. It calls this problem calls as a writer starvation. And so this was investigated, and we switched to the parking lot. It's a library that implements fair locking mechanism. So it's kind of mitigates the writer lock starvation, because they have a special writer waiting queue. So basically, when readers trying to acquire the lock, and they see if the right is one, like there is a writer who is also want to do that, the writer goes first. And the goal is basically, like, the problem what we're trying to solve is that the queries which are reading the state, they should not stop or should not pause the block production. So basically, when during our stress test, what we saw before, when you doing many queries or you broadcasting many transactions and checktx call is calling, that's also acquired the read lock, they kind of pause and block the block production process. That's and the mitigation is our first mitigation was to use the parking lot. But we'll talk about it later. Another problem was that we read state during the query multiple times. So it could be a situation when we started the query, and some user reading the data, we read some part of the state first time, and then new block arrived and was committed, and the second part of the query reading state again, and you're getting the different information, which kind of inconsistent with what you read before. So the goal was to have the consistent state for the entire the query or checktx call. So we kind of refactored all these methods to make sure that we are accessing the reading information from state only once. But that's not all. So since the parking lot is solving the writer lock starvation problem, it's still not good enough, because since you have this wait for write queue, you still have a readers who is reading data this moment, and the consensus should wait until all current processes, like current threads who is reading current requests, who is reading the state, will be finished. And like during our stress testing, we saw like 500 like check TXs calling at the same time. So it kind of pauses the block execution process because it needs to wait until all of them will be done. The currently executing calls will be done. And solution for that we found we discussed it actually, like how we can mitigate it, and we discussed, since we have like we reading a lot, but we're writing pretty rarely, like only at the end of the block, when we completely process the block, when we do block commit, we updating the state, we basically replace it in one like atomic step. And it might be better solution when we don't need actually to block the readers and even like to using even logs, but we could have a system when we have like kind of two versions of the state, current and previous, and we replace them, we swap them for some time. And fortunately, we found a pretty nice implementation of this algorithm. It calls arc swap. It's something very similar if you're using the arc together with read-write log, but it is like log-free solution. So it works in a way that when you're reading the state, you're getting the reference to the part of the memory. And if this part of the memory is replacing at the block commit, then you're getting the actual data back. It's like updating your, you still have the old one, but in the memory it replaced to the what we swap. I'm not sure if I'm explaining very well right now.
I think what the viewers
I can explain it properly, but it will be so technical. So I'm not sure how to explain it easily, you know.
Can I give a very quick go? Very quick.
Yeah, sure.
A very quick one would be welcome.
Okay, so basically, in terms of like ways that this can be fixed, there are multiple levels, right? There's the lowest, like rudimentary level, which is basically just use a ref cell. That's really ugly, and you're going to get a lot of bugs. Then on top of that, there's something called a mutex. I think if anybody has ever done any basic computer science class or anything like that, a mutex is basically if I try to get something and somebody else wants it at the same time, you know, they can't get, only one person can use that data at one time. Then on top of that, there's read-write locks. Read-write locks mean, okay, when the multiple readers can read at the same time that one writer uses it. But the read-write lock that we had a problem. As long as people really want to know the data, meaning a lot of queries go on, the writer can never write into it. And that's really bad because basically more queries could break our system. So then we use parking lot, and parking lot basically same thing with read writes, but the writer is basically going to happen. If I say, hey, I want to write, you just have to wait for the current reads to finish. Okay, that's not that bad, but wait, there could be thousands of reads at that time, you know, and the reads could actually be taking some time, and that would pause execution. Don't do that. So now we're basically at, okay, what is the golden solution, you know, the stuff that only like master developers can do? And we found it. It's arc swap. It was actually between a talk between me and Ivan we actually kind of were discussing like implementing this ourselves, and then we found a library that does it. It didn't do exactly what we wanted, but almost perfect. So then, you know, we replaced it with arc swap, and everything was beautiful until we found the problem. And Ivan, you can continue.
Thanks. Thanks. And I would just add that read-write locks, it makes sense when you do multiple writes as well, when you're doing writing a lot as well. But in our case, we do write only once when we commit the block. That's why arc swap is very, I mean, this approach is very suitable in our case. That's it's very, it depends on the case. It's not like arc, it's not like arc swap can replace read-write locks in all cases. No, it's only the case when we have a blockchain system and then you write at the end of the block, when you have really, really rare writes. Yeah, but it was another problem. Yeah, so thanks. So another problem was that we basically have two states, right? We have the execution state, what I was talking before, what we need to share between the threads. And we also have the drive state, the thing, what we're storing, the data, what we're storing in GrowDB, the actual platform state. And the problem is when we're swapping the platform state, so updating the platform state and updating the state in the GrowDB as two different operations. And it happened, so if it would happen atomically as one step, all would be good. But it's two different operations, because in case of GrowDB, we have RocksDB transaction underneath, right? And this transaction is committed. And in case of the platform state, we use this arc swap shared log. And these two operations happening as two different steps. And what we observed during our tests, that, whoa, we see the inconsistency in our queries when part of the information is from the current block and part of the information from the previous block. And actually part of information from the previous block is from the GrowDB, and the information which is for current block is from the state. So it's clearly, they have some race condition, the data, for our data.
And just to point out, this was happening about 1 in 500 queries.
I mean, you need to make intense load on the system to actually see it, because it's like milliseconds of difference between these operations, and you need to to be right in between. So as a solution, we implemented. It was actually the interesting custom solution because it. So we discussed multiple options. Of course, one of the options to let's go back to the logs and just open the log before you're writing the state and release the log when we committed the transaction into GrowDB. That will make sure that this operation is atomic, right? But in this case, we're losing all benefits, what we discussed above, to having log-free reading for the platform state during queries. So then we still need to wait until block is read, or when we commit the block, we need to wait until all the current queries will be finished and executed. So we basically go back in this case. And we came up with better solution when we're basically using atomic number that represent the atomic Q64 that represent the current height, and we update. So we change the height when we store the state, and update this counter when the transaction is committed. So basically this atomic counter is represent the current height of the committed data in transaction. And having this, we were able to update the logic of the queries and implementing the, I would say, optimistic approach of reading state. So we're reading the state, and if we see that atomic So we're reading the platform state, the execution state, we see the height, and we're reading the counter, and we see the same height. And just to be clear, this atomic counters is very, very fast. It's lock-free, right, Sam? And
it's lock-free, and it's even more than lock-free. It's in relaxed memory, meaning that it's basically the fastest type of lock with the lowest amount of guards. And that is actually completely what we wanted.
Yeah, so basically we have a lock-free solution for the state, and we have this lock-free counter, and we compare the heights. If the heights are good, I mean the same, then we continue the query execution. And it's I would say 99% of cases, right? But if we see that the counter is lower, it means that transaction actually is not, to GroveDB is not committed yet. Database transaction to GroveDB is not committed yet. And in this case, we're waiting until the transaction is committed, until this counter is increased to the high what we need, and then reload the state and process the query.
Yeah. Basically, I think we need to move on, because this is actually not, we've done so much in the last 2 weeks, and we're spending a long time on this problem. It is very, very interesting from a technical perspective, because in my entire career, I've never built something like this. And so it is, I think, like, basically you're hearing me and Ivan a little bit geek out on this solution, because it is very interesting. No, we have been geeking out. We're not going to do it anymore. We're passing a lot. Well, maybe. I don't know. The last thing that I do want to say, though, is basically one query out of 300 is going to fail, right? The solution is basically that when it fails, that's fine. Queries are fast. In that thread, it's just going to redo the query and give back the solution to the user. So, like, we're okay with that. Right now, we have absolutely no way to stall consensus through queries anymore. And that's the big takeaway. The system will chug on. There's no way to attack it. Let's move on.
Yeah,
Goal
thank you very much.
accomplished.
Yeah, goal accomplished.
Goal accomplished. And we are 30 minutes in. So we have half an hour more.
We should do a mission accomplished on a big on a cruise ship. I don't know if
thank you very much.
But anyways, let's move on. Okay, so I'll take this one quickly. So basically, we had a problem when the mempool was full. There was no way for a user to increase the priority of their state transition. So let's imagine that I wanted to create a new identity, but currently the mempool is full. You know, like people have been spamming it, or platform is crazy popular. It's doing hundreds of transactions per second, or like it's at its limit. And, you know, the mempool's full, you know? So what do you do as a user? Well, there is a market, and you can just pay more. Now, it didn't exist before. You basically just increase the fee that you're willing to pay. Now, you only increase the fee for processing, not for storage. So you basically put a multiplier on the processing costs, not the storage costs, because the storage costs are not, I mean, they're always going to be the same. You just pay more for the processing of the state transition. And if you put like a 1 in that field, so 0 means no fee increase, 1 would mean 1% more, 100 would mean 100% more, 1,000 would mean 10 times, 9 times more, because 100 means twice as much, right? So yeah, something like that. So it's all done, it's all merged in. Oh, the previous one was also all done, all merged in, and also on testnet. And we'll talk about like testnet later. Okay, moving on. We have so many different things. Another big part was, you know, I'm going through all our state transitions to make sure that no state transition could hurt the system. Like people cannot attack. So what did we do here? There was double data contract validation, and that's really bad. You don't want to do like much more operations than you need. So that was removed. So basically data contract, so inserting a data contract in the system is going to be a lot more efficient now. There was also, I would say, 50% of different things that could cause the system to basically create a system error instead of a consensus error. If you've ever worked with HTTP, one would be the equivalent of a 500, the other one a 400. 400 means you did something wrong. 500 means the system has a mistake. So these are actually issues where the user did something wrong or is trying to attack the system. And those all make a consensus error. These before, basically, a lot of validation would happen on the mempool validation. This is bad because you're basically sending state transition to the system, and the system is doing a lot of work for free. And you don't really want to do that. You want the amount of work that the system does for free to be extremely minimal, like very, 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 very small, especially if the user is trying to attack the system. Remember that all the validation can happen on the client side. So for there to actually be a mistake that gets sent to the platform, it means that you need to either have custom code or that you are trying to attack it. And most likely trying to attack it is what's going on. So what would happen in this case is the state transition would actually be processed not on mempool validation, but instead by the proposer. And the proposer would still include it and just mark it as invalid. And then everybody else in consensus would verify that it's also invalid. And at that point would charge the user a minimal fee to prevent attacks on the system. So that's all done. Yay, another thing. Let's go on. Created and updated ad variants. Okay, this is another big one. So created ad and updated ad used to use client-based times. What is this? So when I created a document in the system, right, like I wanted to say that I own this plot of land in Italy. There we go. And it's like a data contract showing all the ownerships of land. So I say, hey, I created it. I bought it. And I send out the state transition, and I would say, like, I bought it now. Now let's imagine that the mempool is full, right? And the thing happens. I mean, I send my state transition. I did nothing wrong, but it just stays in mempool for a while. Well, eventually the created ad is going to be very different from the server time. And we had validation verifying that the created ad and updated ad that the client actually provided to the system was within a window close to the block time. And that would basically mean that state transitions would expire because they would no longer be close to the mempool time. So instead, we now do, you no longer put in the created ad and updated ad. You just say that the document requires them, the document type. So the user, the client library no longer puts those fields in, and those fields are instead done when the block processing happens. And then there's there's no problem anymore. And yeah, this is actually something that I've wanted to do for years. And on a weekend, I was like, I want to do it. So I just did it. We also introduced block height and updated, so created at block height and updated at block height, and created at core block height and updated at core block height. So this basically is the same concept as created at and updated at, but uses block height or core block height. So block height is the platform block height, and core block height is the core chain block height. That's also kept in consensus through platform. And so what is the purpose of this? It's actually synchronization. It can heavily synchronize between other apps. In fact, it's going to be very useful for DashPay because you can send when you send a contact request, like say I want to be I want to be able to pay Balash here using DashPay. You put in the created at core block height as a requirement in your data contract. And that basically means that when the processing of the state transition happens, the core block height is automatically taken from platform and inserted into the document. And that's really cool. Why? Because at that point, when the user queries it, you know the core block height at which time he could have started issuing transactions between the users, right? And you would actually know at what time to start resyncing the blockchain if you're out of sync, right? So with this feature, there's no longer any possibility. Basically before, what we were doing in DashPay on mobile was that we were making an estimated guess and resyncing from then in specific cases. At this point, we no longer have to make any estimated guesses, so there couldn't be any transaction missing. Now, there wouldn't really be any transactions missing as long as you weren't using DashPay on multiple devices before. But now, even on multiple devices, it should be fine. Okay. We also did the same thing for key disabled at. So like when you update when you had an identity can have multiple keys associated to it. They were able to set a disabled at, and we were also verifying that this disabled at was close to their system time. And now you just say that it's disabled, and it uses the block time at which it was disabled. Okay, cool. How quickly have I done that? Okay. Okay, we did a lot. Fixing identity state transitions. So we had these withdrawal keys during validation, as I was looking through everything, I realized, well, they're not actually being used for withdrawals. They were supposed to be used for withdrawals and transfers of credits between identities. Now we're just renaming the whole type of key a transfer key. And transfer keys are basically an authentication type key, but they're only used for withdrawals and transfers. And they were not actually working at all. And now they're working. So they were not being able to, you weren't able to add one to the system. You were not able to search for them. Yeah, so that's all done now. Yeah, and then we had some stuff with consensus errors. That's not very interesting. Let's move on. Yeah, before there was a lot of like stuff that's not ideal. Like one thing in our system is that you could only it wasn't actually forcing you to add a master key. And if you didn't add a master key, you would never be able to update your identity. Now you have to have a master key. You also have to have exactly one master key at a time, meaning that if you update and you disabled your current master key, you have to add a new master key. If you're trying to add a new master key, you have to disable your current master key. You can only basically replace it. Yeah, there was one of the most expensive operations on our system is something called proof of possession of keys, right? And we moved the identity key proof of possession to a later part of validation. Basically, before, if it was not good, the user would not pay for it, and that could create an attack on the system. Now it's moved to a part of validation that in consensus validation, where if the proof of possession is incorrect, then the user has to pay for it. And there's no way that a normal user using the system is going to have this problem, right? It's literally only for attack. So basically the point of a lot of the work over the last 2 weeks is if somebody attacks the system, they pay for attacking the system, right? And, I mean, I welcome it in the future because that means the Mazda owners will get rich. Please attack us. Please lose your money. Yeah. So yeah, there's also another one like identity update was able to disable a key that it was also adding, right? So that's a little bit why that's not good. So that's also fixed. Okay, next one. Oh yes, Ivan, you want to take this slide?
Thanks. Yeah, I will do it really quick. So as you already know, we reviewing our code to find some issues and problems, and this was one of them. During our work on multi-threading and making sure we have consistent state, we noticed that we are actually the versioning, the platform versioning, how we call it, is inconsistently used. And to remind you, the platform versioning, it's about the upgrade of the platform to the new functionality, and for specific blocks when new epoch is started, if the proposers before voted to switch to the next version, we're switching to the next version, and new block with the new epoch will be processed with the next version. And reviewing the code, we found multiple inconsistencies during the block execution, the previous and new version.
Ivan, let's not make this out to be more than it really is. Like, basically the first, I mean, we don't want to scare the viewers. The first block of a new epoch was using the previous version for block processing. It's not crazy bad, and we'll fix it.
I'm not saying it's crazy bad, yeah, but if as we already discussed, that the first block of the epoch should be processed, so basically the whole epoch should be processed on the same version, right? And otherwise we could have some issues when we have changes with new protocol version that affect the fees, so they will be calculated improperly. I'm not saying it's like evil and like the blocker for the whole platform. It's not a big deal to fix that. And so we're working on this right now to align and making in order the versioning process in the platform.
Yeah. So basically, just we need to make sure that one epoch, so like one bunch of time of platform, there's one version. That's it, and not one block off. So we're gonna get this done. Ivan's on top of it, and I'm sure this is what we've been talking about kind of today and end of last week. So it's something more recent that we discovered. So it's normal that it wasn't planned at the beginning of the last 2 weeks. So we did a lot of the previous work, and now we're just adding extra work that we discovered. Okay, excellent. Thanks, Ivan. Yeah, so there's actually 3 other fixes. I'll quickly talk about them. Pasta has been amazing in helping us fix warnings. We had hundreds of warnings because we're coding as quick as possible, and sometimes some creep through. The warnings are generally stuff like this thing is not used, right? Often, so for people not to be worried, a warning doesn't mean the code is bad. It just means that you're adding like an import that you don't need. And it's often like you're leaving in code that you don't need, or there's a slightly better way to represent the same code to make it more understandable to developers. So he fixed all of them. Thanks, well, not. I would say the vast majority of the main projects have been done. So thanks, Pasta, a lot. We also had I think Paul, you did this random contract creation. So that was done. Yeah. We had a testnet fail and go down about a week ago. And that was because during one of our updates, we used the wrong state to get the current validator set. And because we used the wrong state to get the current validator set, it was basically creating a situation where the validators were one set and the proposer was not actually in the validator set. Which obviously can happen, and it causes platform to go down. That's been fixed. That was just a regression that was introduced with a lot of the recent PR. So it wasn't a long-standing issue. It was just a more recent issue. Okay, cool. Yeah, I think, do we have more platform slides? Oh yeah, we do. Igor.
Finally. Hello, guys. Nice to meet you, everyone. Yeah, so this week we were doing some improvements on our queries interface in Drive ABCI. So we managed to fix internal error happening on getProofs call in the cases where we are asking for proofs of data contracts, identities, and documents, all of them simultaneously. We also fixed an internal error on getIdentityKeys query. We removed deprecated call to the broadcast TX sync of TenderDash. It was a minor refactoring at the TenderDash site, and basically nothing changed. Broadcast TX sync is just an alias to broadcast TX. Yeah, and we removed get identities and get identities by public key hashes because of their performance intensity. And this pull request is in review, and we are about to come up with another query that will replace get identities. This is needed for DashPay to fetch contacts. Yeah, and finally, I had an opportunity to get my hands on RS SDK. Yeah, and currently I'm adding an extra endpoint just to see the internals and how the thing is working. So, yep, thank you. This is it from my side.
Yeah, thanks.
Thank you. Paul.
Yeah. So I worked on strategies and the platform terminal user interface. The main things I did was I basically added support so you can import and export strategies from GitHub. So you can like export a strategy to a file and add it to a repository. And then you can basically copy the URL from that repository for that file if you want to import a strategy. I added like a command line interface for strategy tests, so you can just run strategies from command line. You don't have to like open up the app and everything. Yeah, added some more features in the interface like that aren't related to strategies, like fetching contracts by ID, clearing the loaded identity, and which, you know, if you're using it, you'll know what that means. Some bug fixes and updated descriptions for the strategies library, which was pretty out of date. Yeah.
Yeah, and those are always very appreciated because when you publish it, it automatically makes documentation, which is very nice.
Yeah. Thank you.
Thank you very much. And now Evgeny.
Hello. So, a GrooveDB visualization tool. We recently restarted our work on GrooveDB because for some time it was stale because it was kind of released, but still we had no tool to debug it and to visualize it properly, and it could cause us some trouble in future. So we decided to do that, and I'll show you a quick demo of how it may look like, a prototype, I mean. So I'll take over the screen. It should become full screen, hopefully. Yes. So this is how an example GrooveDB may look like. As a reminder, GrooveDB is a database solution made of subtrees. So here we see nodes as subtrees of a GrooveDB, and these green wires are references. And because GrooveDB is kind of unique, so we have challenges in terms of UI and UX. So that's the first version, how it looks like, maybe a bit different in future, but still, yeah. So what it is each node I call the subtree because internally it is a tree, right? So it's a Merkle tree we use. Be zoom in also. Some glitches, but never mind. And some example of references we have, it's this one. A loop back is sibling reference because one key can reference another key in the same subtree. Could be absolute path reference somewhere way above it. Could be a cousin reference because we swap parent, basically swapping the subtree key of this parent. And for the sake of visibility, I use strings, but still one should notice that every key is just bytes, and it just happened that they are UTF strings. But we could use hex, we can use integers because in platform we use integers for some subtrees, like for identities or keys. So yeah, that's let's call the version 0.1. When we can finally see an actual GrooveDB.
Yeah.
How complicated it is.
Can you click like on the middle one to see what it looks like?
This one.
Yeah. Oh, okay. So
Yes,
basically, like so we're referencing level 1, 2, key 1. Can you go in there again?
This one.
Yeah. So we're referencing level 1, 2, key 1. Okay, so we're referencing the one in the middle, right?
So here,
Yeah.
key 7 of this one references a key 1 of this one.
Key 1 level 2, key 1 level 1, 2, key 1. Yeah. Cool.
Yeah, that's how it's called. Yeah.
I mean, the thing is that it's not very visible here, but GrooveDB is actually kind of magical, right? Because it's each one of these subtrees that you see by going into the actual tree can either be an item or it can be a subtree. So I think that one thing that we should do is basically have different colors, Evgeny, for the items, for the references, and for the subtrees. And then and then even for the sum items, we can have the sum item trees and like show how the sum items go up to the root, and that would also be extremely cool. But this is a great version 0.1. And I think you told me that this is compatible with web eventually.
Yes, most of GUI frameworks in Rust, there are not many, and they are all work in progress because GUI in Rust is a long story. But yes, most of them are targeting web as well. So they have all of that from the start. Some of them
Yeah.
are just reusing web views. Some of them are entirely different things, but all of them trying to target web because it's 2024. Everybody wants that.
Yeah, exactly. So basically, the long-term goal here is to, I mean, this is obviously something that's amazing, but very rough still, right? The long-term goal would be to eventually publish this so anybody can look directly into all of the platform data to debug it, you know, even if there are 1,000, I mean, they basically would only see like a specific part of GroveDB at once, right? You're not going to load the entire thing at once, but you would see like a little section, and then you could go to a subtree and see like the vicinity of that subtree, and then you could basically go around all of platform data to go and look at whatever you want, really.
Yeah, that's correct.
So
All of them are loaded on demand. I just demanded them all.
Yeah. The point is that it's going to be really, really cool to basically be able to just navigate around like billions of these nodes and see everything. So thanks so much, Evgeny.
Thank you, Evgeny.
Thank you for having me.
So I think that was the end of platform, but there was something that we were missing, and that was the work left. I realized we didn't talk about the work left needed before we're able to release this attackable, non-attackable version, right? So it's actually not that much. We released Dev 9 to testnet today. And that has everything that we talked about today that was marked as done, as well as all the internal things that we didn't have it done label at all, right? That was all considered done. So that is actually like a big improvement over just 2 weeks ago. And I do think that version is going to be a lot more stable. It's not yet it's not ready yet to be attacked. The stuff that is left there is that identity creation and identity top-ups are still pretty expensive in our system, and we need to find a way to solve that and to make it so we can attack the system with identity creates and identity top-ups. So once we have that, and there's also a small part on document updates that we also have to review. So once we have those 3 things done, and probably a few other fixes that we come up with, a few things that are in progress, such as like the versioning, we're going to release a version probably sometime next week. And along with a long document explaining the validation that's currently 18 pages long. When I say that I've been working on documentation, there is quite a lot. And basically with the document and that release, we're going to basically ask to start the attacks and see what happens. My hope is that will last more than an hour. But it will be very interesting, and we'll also be attacking it internally, right? Paul is definitely has his strategies ready to start those to start breaking it. So
all right, shall we move on to core team? Pastor,
All right. Thank you, Balazs. Well, as our time is up, I will be skipping over my slides so we can go right into. All right.
That's okay. Just go.
Right.
All right. So there's not a whole ton that I really want to report this week. We did release version 20.1, I think, right about 2 weeks ago, because I released it on last call. So we're going to have an update on kind of the percentage of people upgraded to that. The major task that we're working on is really moving towards BIP 324. It's hard to show progress on some of this stuff because they are incredibly long and big tasks with a lot of refactoring and a lot of just moving of code around and a lot of reviews. So Kitty Whiskers actually did a really solid job this last 2 weeks. He got a lot of really major refactorings done and merged, kind of a bit of modernizing the code base, making it more resilient, but ultimately moving us towards the future of P2P encryption. So that's kind of the main thing that we really worked on. Descriptor wallets is basically done. There's a couple of things kind of broken with it right now from the update that I got today. I think CoinJoin is having issue with descriptor wallets, but this is an optional experimental feature that isn't really used by anyone. It's just a thing that we're moving towards. Descriptor wallets are really also more of a refactoring than anything else. It's just kind of technical stuff. It's nothing super interesting from a user experience perspective, but we did make significant progress on backports and these refactorings that move us towards kind of major V21 features. But anyhow, we can move on, and we're going to see on the next slide, version 20.1 has gotten significant adoption already, about 23.5% or so. Basically, everyone's on 20.x as we would expect. Really, everyone should be. We have about 140 Evo nodes, so that's cool. But about a quarter of nodes are updated to version 20.1. So pretty happy with that. We haven't had any reports of issues on 20.1. Doesn't appear to be any regressions or issues so far, knock on wood. But happy that that release is going well, and we of course encourage more people to update to it, but should be just as simple as updating the binary. All right, we can move on to the next slide here, and we'll see the list of PRs done this last week. As you can see, almost all of them are really kind of backports. A lot of backports. A couple of things related to the V21 release process, but a lot of backports, a lot of refactorings, a couple of things in like CI. But overall, a good set of weeks, but nothing really that's super visible or super explainable. One of the kind of cool things is I worked on basically decoupling our process a little bit from GitHub. We now don't rely on we basically don't rely from a security perspective on GitHub at all. They're not creating any commits for us. They're not signing any commits. Nothing like that. So everything is done locally from Git's perspective, and then GitHub is simply a mirror. It's just a place that we push commits to, and it's a place to, store discussions, but none of the actual commit creation or anything like that is done on GitHub anymore. So that is nice from a resiliency perspective that, now if GitHub disappears someday, we could really easily move to something else, but also just from a security perspective that even if GitHub's, signing keys are compromised, which is very unlikely, but could happen, it wouldn't affect anything as we're not relying on their signing keys in our Git process. So yeah, that's kind of cool. Anyway, I think we can move on and go over to mobile.
Very much.
Right. Thanks, Pasta. So yeah, we can start with the Android slide. Had quite a bit of stuff in the sprint kind of all around. Some small bugs on Dash Wallet were addressed, as well as probably some of the more robust testing I think that we've done on the Rust libraries so far. So that's good. Coinbase custom tabs, we finished that this sprint, and that was a necessary change due to some other changes that they made to their APIs. The default purchase amount on Topper was finished. That carried over from the last sprint. There was a good amount of carryover from the last sprint, including the CoinJoin stories, some of which are already done now. And there's been a lot of back and forth on the testing of the Maya integration for the enter amount screen. So that work continues. And then for iOS, again, Rust libraries, external crates is the current focus at the moment. The same topper change. We had to hide Coinbase in the UK storefront to try to appease the Apple review guidelines review. And then a lot of CoinJoin work was accomplished and finished, and they're moving into the next collateral related work. We have started the alpha testing for CoinJoin on Android. So that was released yesterday. We don't have too many people. So if anyone wants to sign up, you can take a look at either our latest newsletter, or you can send an email to the support team and they can give you the sign up form for that. We also are looking for people who want to participate in the Dash Spend beta. Still waiting on a final release date for that. The production rails are still getting set up, but we're ready to go. So as soon as that gets activated, we'll be reaching out to people who have signed up. Same for that. You can email the support desk and they can give you a link to the sign up form. So that's it on mobile.
Thank you very much. So let's move on to the questions. We have one question so far, which is any improvements on the 90 transaction per second with the ARC swap changes? You are on mute.
Sam, are you talking? But you muted.
Sorry. I was muted and the button wouldn't unclick. Okay, yeah. So our transactions per second is around 80. We see 90 sometimes, but I think it's better to talk about 80. And I think we tried it out and it stayed around 80. Because this is more during our testing, right? We were not querying the system like crazy. We were just doing, spamming state transitions. So the point is that with the spamming of queries at the same time, it would have been much less than 80, much less if the system could actually advance at all. 80 was with no queries. But now, like with queries, it will it will still be 80 or so, because those threads are at max CPU on that process. So that's pretty much the answer. Staying at 80.
So for block production, it's another bottleneck. It's already
we have a solution to go to much higher transactions per second. The vast majority of usage is on something that we don't really need in GroveDB. I mean, we need it, but there's a way to improve upon it and to remove like probably more than 50% of the processing CPU costs there. However, that takes time, right? And it probably would take 2 weeks to 2 weeks to more than 2 weeks. I mean, I don't want to give out exact times. And we probably would triple, well, maybe not triple, but we'd at least double our transactions per second, probably going to about 200. We're not doing that. Why? We can do that in the next release, right? We can do it in version, well, it would actually be version 2, but we can do it like 2 weeks after the release or 3 weeks after the release. Let's just release. The thing that we need for release is that the system can't be attacked easily, right? That's what we should focus on, not transactions per second. If anybody thinks that we're going to be getting 70 transactions per second on the first, well, maybe on the first day, right? But if we're, I don't think we're going to have 70 non-spam transactions per second on release. We might, but if we
then
do,
we succeed.
That's a nice problem to have, right? And the thing is that we know how to make it a lot stronger, which is half the battle, right? We know what to do to make it, much more, like more than double that, and we can do it within a few weeks. So let's just release, guys.
that was nice to see the Balazs's eyes. He was like really scared when we say like, oh, we know what to do. It takes 2 weeks. He was like super scared, and then we do next version, and he was like full relaxed. Interesting game of face.
We all want to release, you know? It's gotten to the point where it's like, okay, is this necessary? Is this arc swap stuff necessary? And then yes, it is, because anybody could just like query platform 1,000 times and the platform would go down. Like, we don't want it to go down in the first few weeks just because of, I mean, we need to make it so it's it won't go down. It's pretty much the bar to set right now.
Yeah,
but
that was
anything,
actually the goal for the stress test, right? I mean,
yeah,
so basically this couple months of work what we did, it's like basically to make sure that the platform is stable and we cannot stop the block production, and we achieved that, and that's it what we need for this moment.
yeah, exactly. So it's going to be very very interesting next month and or two. Like, we are, you know, I would say that the team is going very fast right now, because it's you know, when you get closer to the end, you see the light, right? And we all want to release in the bull market. I personally believe that the bull market has not ended. Every single bull market that we've had, all the way back to 2013, or even the $1 to $30 for Bitcoin in I think it was like 2011, 2009. I forget that one. A long time ago. I did not know about crypto at that point. All of them, they had this dip, right? Early on, right? So I do believe that we're going to see a much continued bull market. And we definitely want to release platform during it. Okay. Do we have any more questions?
We have a quick question. What's the largest thing that can store on GroveDB's key value store?
Oh, what's the limitation?
Yeah. I think that was one of the questions asked in Ryan's incubator.
Do you have any limitation for state transition anymore?
For the state transition, we do. I believe, I forget what it is.
It was
there
16 kilobytes before, but now I'm not sure we have it.
No, I think it's there. I think it's, but we're not talking about, I mean, the question is only GroveDB, right?
Yeah, it seems.
Well, so there are two answers, right? If you're using platform, it's limited, because well, there's many reasons to limit it. But if you're using just GroveDB, I think it's 65 kilobytes. I think I'd have to check that and get back. It's either 65 kilobytes or there's no limit. Or like very high limit, like 4 gigabytes. But the from platform side, we are not, I mean, the data, so it's in the data contract max size, remember, Ivan, for documents? It's there. I forget exactly what the value is, but it's a few kilobytes, if I'm not mistaken. All the way, the max value that it could be is 16 kilobytes. But I'd have to check.
Another quick question. Is it possible to get an estimate of cost without sending a state transition?
Yes. Yes. There's in Dash Platform Protocol, there's you can say like, how much is this state transition going to cost? We haven't exposed that in the Rust SDK. We probably should. Yeah, we'll probably expose it. It's very simple. It's just a little call.
Yeah, and do this
Okay.
validation before you send against the balance, right? On
Yeah.
client side.
Yeah, it's a
Thank
good
you very much.
thought.
Thank you very much. That's it for today. Thanks for being here with us, watching us, giving us feedback in the chat. We appreciate that. And thank you for the questions as well. And see you in 2 weeks.